Okay, so for lesson 6 on word problems, a couple of quick definitions that we often run into is angle of elevation and angle of depression. So whenever I see this word, these phrases, angle of elevation or angle of depression, the first thing I want to do is draw myself a horizontal line. So this horizontal line here, okay, or this horizontal line here. So the angle of elevation is the angle between the horizontal and the line of sight. So from the horizontal kind of up, and from the horizontal down would be the angle of depression, the angle between the horizontal and the line of sight from an observer to an object. So for example, if we're looking at this picture here, a man looking up at a plane, the angle is from the horizontal up, angle of elevation, and the angle of depression is from the horizontal down. And of course, drawing diagrams can be a little bit of an issue, so we'll practice that a little bit here. A ladder is 2.5 meters long and rests against a house with an angle of 63 degrees between the ladder and the ground. Determine how far the base of the ladder is from the house. So here's just a typical kind of question where we're finding a house, or the house is not drawn, so we're going to draw the house, and here's the ground. And we can presume that the ground and the house are perpendicular. Okay, that's an assumption that we kind of have to make. And here's our ladder leaning against our house. So let's just read the question again. It says a ladder is 2.5 meters long, so I'll label that as 2.5 meters, and rests against a house with an angle of 63 degrees between the ladder and the ground. So where would that angle be? That ladder's angle is going to be on the ground there. That's our 63 degrees. And determine how far the base of the ladder is from the house. So the base of the ladder, the bottom of the ladder from the very base of the house. So X would be right here. Okay, that's what our unknown side is. Once we get the diagram set up, the rest is fairly straightforward, I think. We're still using our SOHCAHTOA rules. Okay, and in this case, we're looking for a side length, so I know I'm going to have to cross multiply. So I'm going to say the cosine of 63 is the adjacent over the hypotenuse. Okay, this is our adjacent and this is our hypotenuse. And this would be our opposite that we don't really need to concern ourselves with right now. So cos of 63 times 2.5 is equal to x. Okay, so our side length there would be 1.1 meters. It doesn't say here, but usually we round to the nearest tenth. So 1 1/10 of a meter, we'll say. Let's just skip number 2 for a second. Let's go into number 3. This is a good one. From the top of a lookout tower, 35 meters above the ground. So here's a lookout tower, okay? And there's some person in the top of this tower, we can presume, okay? And there's a park warden, okay? And apparently she has one leg and very little hair. She spots some cubs at an angle of depression from the top of the tower. So let's just draw this diagram. We're obviously making a right angle triangle. And here's some bear cubs down here, okay? There's some little bears, okay? Bear and her cubs. And at an angle of depression of 59 degrees. So there's our triangle. Where's the angle of depression? So remember, whenever we see this, we're going to quickly sketch a horizontal line. So where would that go from? That would go from right here. There's our horizontal line. So the angle of depression of 59 degrees is actually outside of our given triangle. So if I then label that triangle, or the angle rather, this is 59 degrees here. So if that's our 59 degrees, and this was 35 meters, the trick here is then, where do I find the angles inside the triangle? The angles inside this one here would be 90 minus 59, which would be 31 degrees. Okay, I don't have a very accurate scale drawing here, but if that's my 31, then it says determine the distance of the cubs from the tower. So we're looking at where they are along the ground. We don't really look for the horizontal there. The tower, the base of the tower is here, right? This is our tower. And so there's our x. The trick being, again, drawing the horizontal line and figuring out how to find that interior angle inside the triangle. So labeling with respect to my angle now, there's my opposite, here's my adjacent, and we're going to use the tan ratio. So tan of 31 is x over 35. And if we just pop that into our calculator, we're going to get the answer, which is 21.0 meters. And let's cruise on down to the next one. It says a tree casts a 5.1 meter shadow. A tree 5.1 meters. I guess the height of the tree is 5.1 meters. Okay. And it casts a shadow 7.5 meters long. The shadow is, of course, on the ground. Sometimes students get confused and think that the shadow is the hypotenuse of the triangle, but the shadow is on the ground. So there's our 7.5 meters. Calculate the angle of elevation of the sun to the nearest tenth of a degree. So the angle of elevation, again, this is a tricky one in the sense that the angle of elevation is from the horizontal up. So this is the angle that we're looking for, okay? Even though the sun is up here, which we know, the angle of elevation is from the ground up in this case, okay? That's the horizontal. So our ratio that we're going to use is, again, the tan ratio. This would be our opposite, and here's our adjacent. So we're going to say the tan of theta is 5.1 over 7.5. The tan of our angle is our ratio, and theta is the inverse tan of that ratio. And if we try that, we should get 34 degrees. Okay? Oh, and I guess it says nearest tenth of a degree, so 34 and 2/10 of a degree. This next one says two trees are 200 meters apart. From a point midway between the two trees, the angle of elevation to the top of each tree, the angles of elevation to the top of each tree are 12 and 19 degrees respectively. So let's just sketch out a little diagram here. Here's our two trees. Here's one tree, and here's another tree, not quite as tall. And from a point midway we have one tree has an angle of elevation of 12 degrees, and the other one has an angle of elevation of 9 degrees. And it was a point midway between the two trees that were 200 meters apart, so therefore this would be 100 and this would be 100. So setting up the diagram, again, a little bit of the tricky part. Once we get that set up, the rest is pretty straightforward usually. Determine how much taller one tree is than the other. So I'm going to call the height of this tree here just for ease. That would be x, and this would be y. If I'm comparing the heights, I'm going to then subtract. So tan of 12 will be x over 100, and tan of 9 will be y over 100. And x, looks like x is 21.3 meters, and y is 15.8 meters, and therefore the difference is 5.4. Now, I got this because I didn't round until the very end, so I think if you actually use 21.3, subtract 15.8, yes, we'll get we'll get 5.5. So if we don't round to the very end, our more accurately would be 5.4 or 5. We can sort of we can say 5.5. Okay? In my calculator, I didn't round till the very end. So there's the difference that one tree is. So one tree is 5.5 meters taller than the other. Okay, that's taller than with an AN, right? Then is like next. So I wouldn't say taller than. A little English lesson for us there. Two buildings are directly across the street from each other. The smaller tower is 40 meters tall. The angle of elevation from the top of the smaller tower to the top of the taller is 21 degrees. So this is labeled in here. And again, it's from the horizontal up. Okay. The angle of depression from the top of the smaller tower to the base of the larger tower is 27 degrees. So there's our angle of depression. Determine the height of the taller tower. So I know right away that this height here is 40 from here to here. What we're looking for is we need to find this little missing side right here. This is really our x. This is our x right here, from here to here. Now, before we can find that, we need to find something in this upper triangle. We're going to have to find something that we can use to solve x, because all I have right now is one angle. I definitely cannot find information given only one piece of information. I can only find one unknown at a time, and any trig ratio has 3 blanks, so I need at least 2 of the blanks filled in. So what I'm going to do is look at my bottom triangle and see if there's anything I can figure out here, like for example the shared side. We often can complete and fill in and find that shared side. Now, could we find that shared side? We sure could. I know right away the tan of 27 is equal to 40 over, let's call that y. And therefore y would be 40 divided by the tan of 27. Which is equal to 78.5 meters. And once I know that value, I can then find x. The tan of 21 is x over 78.5. And therefore, x is 30.1 meters. And so the total height will be 78.5 plus 30.1, which is 108.6 meters. Okay, so now for the next question, again, there's this angle of depression. It says from the top of a 65-meter cliff. So this is our cliff, okay? Right here's the cliff. And we've got an angle of depression to D. So D is a person standing there. And the angle of depression to D is 67 degrees. And the angle of depression to Alex is 48 degrees. So let's just draw our horizontal line. Okay, if that's our horizontal line, and then we want to draw that angle of depression right here to D. So if you're an observer up here standing and looking down with very funny legs, okay, you're looking down, and therefore this would be the angle of depression to D. You're looking down, and that angle of depression, it looks like, is 67, it says. And then the angle of depression to Alex here, okay, if this is Alex, is 48 degrees. So then what we want to do is we want to find how far apart they are. D and Alex are standing in a straight line to the cliff. Determine how far apart they are. So this is our x right here. This is our x. However, what to do? Okay, if we knew this whole distance here, which I can call y, and if we knew this little distance here, which we can call z, we could take y and subtract z to find x, right? If this were 10 and this were 3, then x would be 7, right? But how to find that information? So if we look at these two triangles, we've just got two triangles above. What I'm going to do is I'm going to transpose the two of them. So I'll take and we'll redraw the bigger one here. Okay. And this is, of course, this was 48 degrees. So therefore, this inside one, 90 minus 48, is going to be 42 degrees. Okay, and this is 65 meters. And so to find that entire distance, y, that's the opposite over the adjacent. This is our op, and this is our adjacent, opposite and adjacent. So 65 times tan of 42 which would be 58.5 meters. Okay, so y is 58.5. And let's look at our smaller triangle there. The one that's in the white. And again, this is 65. This outside angle was 67. So this inside one, therefore, 90 minus 67 will be 23 degrees. And again, we're going to find the opposite. So tan of 23 is the opposite over 65. And that side length there is 27.5. Or 27.6 rather. And if we then subtract those x's, they're going to be 30.9. So there we see the distance between me and George, which I'm sure you were ever so curious about. That distance is 30.9 meters. Okay, I would recommend that you try a few questions from the assignment booklet. You probably don't have to do them all, but I would recommend that you try at least perhaps probably number 1, maybe 4 to 6, this one's look good, and maybe 8 and 9. And of course you can do more if you would like. Now, I would also highly, highly recommend that we do not miss any from lesson 5. Okay, if you've missed some from lesson 5, you probably really wouldn't hurt to go back and do some of these questions if you need extra practice. And that's it for this unit. Good luck, and if you have any questions or concerns, please don't hesitate to contact me. Thank you.